Hey there, welcome to a video discussing our homework on z-scores practice. So here you'll have 2 pages of work and 10 problems. I'm going to do a few of these problems with you guys and maybe kind of do maybe one of each type of problem. So we'll start with number 1 here. A normal distribution of scores has a standard deviation of 10. Find the z-scores corresponding to each of the following values. Now z-score, it's in our reading, but in case you forgot, it's just this. So mu is going to be your mean. We call it mu. It's a Greek alphabet. This right here is called sigma. That's our standard deviation. So it's also a Greek alphabet called sigma. And x is going to be our data point. And of course, z is the z-score. Now z, what it truly represents is the number of standard deviations above or below the mean. So if you're below the mean, your z-score is going to be negative. If you're above the mean, it's going to be positive. So for example, scored as 20 points above the mean. Okay, well, I don't know what the mean is, but if your score is 20 points above the mean, what this means is that x minus mu is going to equal 20. For example, if your mean were 100, then your score would be 120, right? And the standard deviation told us 10. So the z-score for part A is just going to be this: z equals 20 over 10, or it's going to be 2. So if your mean is 100 and your score is 120, and the standard deviation is 10, that means you're 2 standard deviations above the mean. So the z-score for that one's just going to be 2. That's all. So that should be pretty simple. So you're going to kind of do the same for the other ones. Like for part B, you're 10 points below the mean. So that means that x minus mu is negative 10. So you're going to be doing, your z-score is going to be negative 10 over 10, or negative 1. So I think you kind of get the idea of how to do C and D now. Now let's look at number 2. Number 2 is telling us to find a percentile for a particular z-score. So let me draw the normal distribution. That might help a little bit. So the normal distribution looks like this, like a bell-shaped curve. Your mean is going to be right in the middle. So we call this mu, our mean. Sometimes we also write x bar. I'm going to talk about the difference between those two. Mu is called a population mean. X bar is a sample mean. We're going to get into that in another unit, but we'll just use mu for now because that's kind of the standard that we're dealing with. And what's going to happen is that this right here will be mu plus sigma, which is a z-score of 1. This right here will be mu minus sigma. I could draw it better, which would be a z-score of negative 1. Okay. So when you have a z-score of negative 0.47, I'm going to imagine it's going to be probably somewhere over here. And right in the middle is the 50th percentile. Is a 50th percentile. So I would imagine negative 0.47 will be less than that. Whereas 2.24 is going to be probably way over here somewhere. So I probably expect z-score of 2.24 to be somewhere over here. Whereas that would be a z-score of negative 0.47. So now how do I actually compute that? There are tables you can use, like kind of old school textbooks tend to do that. Well, actually, even the new textbooks do that, but the old school way of doing it was looking at a table. But we're going to use a calculator instead. So what I'm going to do is go to second bars. I'm going to pick option 1. We've been using option 2 and option 3 lately, but option 1 is called normal PDF. So it's going to give us the percentile at a particular z-score. So once you select it, there are going to be 2 things they're going to ask: x value, mu, and sigma. Mu and sigma will probably already be listed as 0 and 1. Leave it that way. If it's not, then make it 0 and 1. The x value, we're going to make it negative 0.47. If you hit paste and then enter in the home screen, you should get 0.357 or 35.7 percentile, which makes sense because 50 percentile is right in the middle. And remember we talked about when you're within one standard deviation of the mean, or when you're, I guess, one standard deviation below the mean, this part right here is going to be 34% of the data. So when you're exactly one standard deviation below the mean, or z-score of -1, that's going to be roughly the 16th percentile. In fact, actually, if I do it right now, second vars, option 1, if I do -1, oops, actually, I made a mistake. Let me fix this really fast. Okay, so actually, I meant to say option 2. My apologies. So do make a correction, sorry. Normal PDF is something else. It should be normal CDF. It's actually what we've been using all along. My apologies. So it should be option 2. So in this case, what I'm going to do, that's good. I mean, it's good to know the mistakes. So what I should have done was lower. Let's leave it as -1 E99. It's probably already like that, but if not, make it -1 E99. Remember to E, you can locate by doing the second and then the comma in the calculator. The upper should be -0.47. And then mu and sigma are going to be 0 and 1 respectively. Okay. So now if I do this correctly, I get 31.9 percentile. And if I do it again for 2.24, I get 98.7 percentile. So that's all you're doing. So you guys can totally now do this for the other ones. Now for 3 and 4, that's to find the portion of cases falling above the z. So you'll do the same thing, but then you'll do 1 minus the percentile. Because what happens is that when you work this out, what the calculator is telling you is the percentage of the normal curve that's to the left of that z-score. So when we're, this is mu, obviously. So when z was -0.47 over here, and when the calculator spit out 0.319, it's telling me that 30.9% is shaded to the left of that dashed line. So for number 3, we ask find the portion of kids falling above the z-score. They want everything to the right now. So in this case, you have to do 1 minus the yellow, or 1 minus what they give you in the calculator. Find it between the mean and the z-score. So what we could do for this one, and actually, you know what? Let me take this back a little bit. You could also approach number 3 in this manner as well. It was not wrong what I just said, 1 minus percentile. But you could also do this too. Again, we go second vars, option 2. Lower, actually, I could list that as 0.24, and the upper just make it a really big number, like 1e to the 99 power. And then mu, of course, is 0 and sigma is 1. If I do that, that would work too. So if I do that right now, second vars, option 2, 0.24, and then 1e99. Yeah, so yeah, so in this case, I get 0.405 or 40.5 percentile. Or 0.45 is fine because proportions can be expressed as a decimal. That's totally fine. And you do likewise for B. For number 4, find area between the mean and the z-score. what you're going to do in this case is you're going to put 0 as your lower and 1.17 as your upper, but keep mu and sigma as 0 and 1. And this is why we call it like a standardized z-score, because you're standardizing your mean and standard deviation. You're centering the mean at 0 and making the standard deviation just 1. So you're keeping it very standard or simple. For part B, you'll do the same thing, but your lower is going to be negative 1.37 and your upper is going to be 0, because you're trying to go between the z-score and the mean. For this one, number 5, you're telling if someone scores a 45 on a cognitive abilities test, the mean is 52, standard deviation is 5, was the patient's percentile. So again, you could just use the whole second vars option 2 bit. But in this case, you can make mu 52 and sigma 5. So when you're doing z-scores, you make mu 0 and sigma 1. But since you're just given straight up what the mean and standard deviation are, of course, you go with that. You want the patient's percentile. So you're going to say the upper is 45. And the lower is going to be 1e negative 99. That way, what the calculator is going to tell you is the percent of the normal curve that's shaded to the left of 45. So if the middle is at 52, then this is at 45, and then it's going to give you all this area right here. And so you kind of take the same approach for number 6. Looking at 7, obviously you can make a Pat the lower, Chris the upper, and work that out. If you look at 8, you have the mean and standard deviation, 35 and 6. You can make 28 the lower, 38 the upper. That should be intuitive. Likewise for B. Now, what number represents 65th percentile, 9th percentile? Now, in this case, you're going to use second vars option 3. So second vars inverse norm. So 65th percentile means that you have your mean right in the middle, and you want 65% of data to be shaded to the left of where the 65th percentile is going to be located. So you put 0.65, and our mean is 35, our standard deviation is 6. You should get 37.3. And do likewise for part D. If you want to be the top 15%, that means that your percentile is going to be 0.85. So you do the same thing. You go to inverse second vars, option 3, which is inverse norm. Your area is going to be 0.85. And of course, you have the mu and the sigma there. The middle 80%, you have to get a little creative with this one. For the middle 80%, it means you want to be between the 10 percentile and the 90 percentile. And so then you do area as 0.9, but also you're going to do area as 0.1. And you're going to share both of those numbers. And I'll give you the range of scores. In fact, actually, if we're kind of curious about that, I could do that for you guys right now for 9B. So if I do 0.1, 500 is my mean, 100 is my standard deviation, I get 371. The 10 percentile, we'll say 372. But do this again. I get 628. So any score in between is going to be the range of values. So that's it. And then finally for number 10, find the z-score that separates this. So separate the highest 30% from the rest of the distribution. So in this case, what you're going to do is you're going to do second vars, option 3 yet again, and separate the highest 30%. So it means that here's mu. So that'll be the 70th percentile over here. So you want all this to be shaded to the left of it. So your error is going to be 0.7. And you're going to let mu be 0 and sigma be 1. Whenever you're doing z-scores, you have to standardize them. So you have to make the center of the mean at 0 and the standard deviation have that as 1. So option 3, 0.7, 0, 1. And so the z-score will be 0.52. And you kind of work out the rest of it in the same kind of fashion there. I believe the area for B is going to be 0.4. And so the highest 75%, so your area is going to be 0.25. That one. Because the way the calculator does it, it's always going to look to the left of where the percentile is. That's what the area will give you. All right, so that concludes the video.